So your flipper isn't working and you're trying to debug why. The first thing you need to do is to check the flipper physically. Make sure that that plastic thing there, which is called the link, make sure that's not broken. Then you inspect the coil and see if it's burnt. If it's your own machine, you'll know that the smoke would have come out somewhere. You would have seen it burn. If it's still nice and smooth, then the coil's okay. Or chances are that the coil's okay. The next thing you need to do is to check for loose wires. Make sure that these little wires are all soldered on properly, because sometimes they just, from vibrating, they'll break off. And they'll hang in the vicinity because, they've been bent to go there for such a long time that you don't really see them. You have to sort of manhandle them a bit to see if they're okay. If they're still okay, while you have the cabinet all upside down and you can access the flipper, you'll have a set of switches on the side here. And in your case, because it's a Demolition Man, it's got a Fliptronic board in it that controls the flipper. So this switch will be, it's called normally open. So when everything is in a rest state, it will be open. And then when you pull the flipper in, something will cause that flipper switch to close. So make sure that there's a switch there and that it's open and that everything looks okay. So now, to make sure the coil is okay, you need to haul out your multimeter and set it to resistance, which is ohm. Let me just get mine. Okay, so that's my little El Cheapo multimeter. I'm going to set to resistance, which is there. And now I'm going to check the coils. Let's just measure between that and that. And you'll see there's a 4 or 5 ohm resistance there, which is normal. And then I measure between that and that. There we go. Switch open. You'll see something like, okay, there's 165, 170 ohm. So the one with the high resistance lets through a small current, but it's got enough current there to magnetize this thing to hold open the coil, to hold the flipper up. And it's done specifically so you don't burn the coil every time you push the flipper. Okay, so that coil is fine. After checking the coils, the next thing you should do is check the flipper switches themselves. Now in your case, you'll have an opto board running the flippers. On these, they'll just make a contact, but in yours, it'll be a board with 2 little black blocks that have a slot in them. Those are the opto sender transceiver switch mechanisms. And when you press the switch, it'll cause a little flap to pull out of the slot of the opto switches. Now, if those things get dirty, it'll never register the opto switch. Now, the switches look somewhat like this. And if you look carefully inside there, you might find a slot. On these you don't, because I think they might just have a transparent resin poured in there. But when those inner surfaces get dirty, then the opto switch won't register that anything has moved out the way. Another thing you might want to check, you'll see all over you have diodes like that. On the schematic, it's a little arrow with a bar on top. Now the bar corresponds to that little stripe on the diode. And to test them, you can put your El Cheapo multimeter onto diode mode and then touch the red lead onto this end and the black lead onto the end with a line. And then your multimeter will try and force a little bit of current through that diode and measure the voltage drop. And on diodes like this, the voltage drop will typically be 0.6, but you'll have diodes like this on the boards. you can check them. If one of the diodes is gone, then chances are that you've lost the protection on these, and then you could blow either one or both of these. Let's say that freewheeling diode is, or that protection diode is blown, then you'll only blow that transistor and maybe something in tandem, but you won't blow those as well. To blow those, you'll have to damage that diode, and you'll have to damage the diodes on the coils themselves, and then you might blow that and that at the same time. So check your diodes as well. Right, so here I have the flipper coil circuits from the Demolition Man manual. And you'll see you'll have two flipper coils, or two flipper solenoids. And each one of them has two little coils in them. That's the power coil, or that one's the power coil, it's because it's marked power. And that one's the holding coil. So that one will be the low resistance and that one will be the high resistance. And there are these two diodes to make sure that when the current stops flowing this way, when the board stops demanding current, that the current has somewhere to go, because in a coil, the current can't just stop instantly. It has to keep flowing until the magnetic field collapses. So the diode is there to keep the current flowing in a little circle there, and the resistance of the coil will actually damp the whole thing. So over here you'll see that the lower right flipper and the upper right flipper are both fed by this red-violet line. Oh no, wait a minute. The top one is fed by a red-green line. So that'll put 50 volts on that point there. And the red-violet line will put 50 volts on that point there. These will go back to the PCB, and they will short that. They will create a short from there down to ground, so the current will flow through the coil. So, having said that, if both flippers are down, then there's something wrong with this bridge rectifier here, because that one feeds both of them. If only one of them is down, it could be that fuse, it could be that fuse. Now that is sitting on the Fliptronic board, and the board I have here to show you, okay, you'll see my board doesn't have fuses, but look for fuse 903 and 901. Maybe they're blown, and you can see that visually, otherwise you'll just have to check with a multimeter. So then change the fuses. Check on this on the specs what ampage they must be, because if you put like 100 amp fuse in there, the coil will blow and it will protect your fuse. If you put the right fuse there, the fuse will blow and protect your coil. So be careful. Put the right stuff in there and put slow blow fuses. I get mine from Mantec, and they're 6 by I think 35 millimeters. They're imperial, so they're actually 1/4 inch by something, but it's a 6 millimeter fuse, glass fuse. So you can see there are two lines here. That is the power coil, because it goes through a fat transistor, and the other one doesn't have that. It just goes through a tip 102. Now this is a Darlington transistor. It can take something like, I suspect they can take something like 10 amps. This fat boy here can take 50 amps, if I'm not mistaken. Sometimes they blow, and then the flipper won't engage, but if you hold the flipper up and you press the flipper button, it'll stay up, because this thing will still engage. So this circuit is for the power coil, and this circuit without the power transistor is for the hold coil, because this transistor in itself has got enough capacity to hold the hold coil without blowing. Okay, so sometimes the flipper engages, but it drops down and starts vibrating, then you know this thing's gone, or there's something wrong with this circuit. Sometimes the flipper doesn't go up, but if you hold it up manually, it's that circuit. Over here you also see these diodes going from that line to your 50 volt supply. That is, if there's a spike here that's higher than 50 volts, the current will just flow back into your power supply instead of flowing back into your circuit and blowing your transistors. So on your machine, you need to figure out which of these pins on J902 is going to which flipper coil. And on your machine, you'll find a board that looks somewhat like this. I think this is a Fliptronics 1. But in essence, it looks very much the same. These are the fat tip 36Cs, and these are the tip 102s. Now, I don't want you to get into too much detail on how to test these transistors. I can show you that if you want me to, but I'm not going to go through it now because it's higher grade and most of you guys just don't have time to do that. You'll just rip the board out and send it to me. So on these pins, the wires coming from your flippers these wires, you'll see that there's a J902 and they're numbered 13, 11, 9 and 4. And on this board, which is the same as your Fliptronics 2 board, this is just marked J802. That's why I reckon it's a different version, but it looks a lot similar. So it's marked 1 and 13. So on pin 1, if you have the connector still plugged in there, you can okay, so this is an old connector that will look similar to yours. It'll be plugged in that way. And you'll see that there is, if it's a IDC connector, in other words, an insulation displacement connector, the wire will be pushed in there and these two little prongs there will cut through the insulation and displace it so that the wire will actually short through on that pin, which means you can put a multimeter onto that pin there. Get your multimeter onto that pin there, and if your leads are long enough for your multimeter, take it down to the actual flipper coil and make sure that you have continuity between there and the actual connector. So continuity on my El Cheapo is that little thing there. It's with a little speaker. So if you turn it to that, that'll measure the actual resistance. So let's measure these cheap leads. And that's not 0, that's 0.2 ohms. That's not bad for a shitty little multimeter like this. But if you put it to continuity and you do the same thing, it'll beep. So you don't have to watch the screen, you can just listen for the beep and you know that the 2 points are connected. So set your multimeter to continuity and check between pin 13 of the connector and that pole on the coil. Sometimes you'll have it on the wrong pole and then you'll measure the resistance of the coil again, but at least you'll know that there is nothing wrong with the wire. If there's something wrong with the wire, you'll get zip. And if there's something wrong with the wire could be cut by, someone lifted up the play field and it got snagged in the corner, it got pinched in a pinch point and it got cut off, or that the connector has gone bad from just vibrating over time. That happens. And I have proof that it happens, and that's because when it happens, the wire vibrates loose, and as it vibrates loose, the resistance of the actual connection gets higher and higher, and it heats up, and then eventually it toasts your connector, and then you have to phone Frikkie. All right, so that's how you test the continuity. If the continuity is there and the coils are cool, then it means something is wrong on these circuits here. And if there's something wrong on these circuits here, then the best thing to do is to extract this board from your machine. In other words, take lots of photographs of those connectors and take photographs, lots of them, of all the connectors and what's plugged in where, so you know where to plug them back in again. Then loosen all the screws, take the board out, call the courier guy and send it to me. And then I'll check all the transistors, and if anything's broken, I'll fix it for you. And we'll see if it helps. If I find a fault on here, then we know, okay, then it's fine. Then I change one of these transistors or I change whatever. But if I don't find something, then the fault is somewhere else. And then unfortunately, you'll have to phone Simba, who has a transport company that'll come and fetch your machine and bring it to me. Because you're not doing it, and I'm not doing it. Because frankly, I'm too old for that shit. Okay. I hope that clarifies your debug procedure for your flippers. If not, call me. Cheers.